Good morning, everybody. Today we are going to solve this practice problem 3.9 from Alexander Sadiku, chapter 3. So, by inspection, obtain the mesh current equations for the circuit given in figure 3.30. This is the problem given. So, we are going to solve this. That is, we are going to obtain the mesh current equations for the circuit. Okay, the answer is also given. Let's check the answer back once we solve the problem. Okay. P. Okay, by inspection method, V equal to IR, this is Ohm's law, we know. Then it can be written as RA equal to V. So we form this R matrix multiplied by I matrix, which is equal to this voltage matrix. So we are going to solve now. How many loops we have? This I1, I2, I3, I4 and I5. So 5 loops. Okay, so for this first loop, let's form this R matrix. So it consists of this 50 ohms plus 20 ohms plus 80 ohms, that is R11. Okay, then the next one is R12. So R12 means it is common to both second loop and the first loop. So it is minus 20. Then the R13. Okay, then R13. So it is common for this first and the third. We don't have anything common between this first and the third loop, so it is 0. Then for this fourth one, R14. Okay, so it is this 80 ohm is common, so it is minus 80. Then nothing is common between this fifth loop and the first loop, so it is 0. Then for the second row, it is R21. Okay, so this is R21. So R21 is the common resistance between the second and the first loop. So it is minus 20. Then R22. So it is 20 plus this 30 plus 15. Then for this R23. So R23 is this 30 ohm. So it is minus 30. And then R24. So it is minus 15. This, okay, this resistance is common between this second and the fourth loop, so it is minus 15, then 0. Similarly, we can write for R31, 32, 33, 34 and 35. So for that, this 31 is nothing is common, so it is 0. 32, this 30 is common, so it is minus 30. Then 33, what are the values available? This 30 and the 20, so it is given here. Then or 3 4, that is nothing is common between these two, so it is 0. Then this 20 ohm is common between this fifth loop and the third loop, so it is minus 20. Similarly, when you go for the fourth row, so it is the fourth loop, right? So this 80 ohm is common between this first and the fourth, so it is minus 80. This one is common between the second and fourth loop, so it is minus 15. Then nothing is common between this 4 and third, so it is 0. And between, and for this fourth loop, it is 15 plus 80, so this is here. And between these two, nothing is common, no resistance is common. Okay, so it is 0. Then for the last fifth loop, if you consider nothing is common between first and fifth, so it is 0. Nothing is common between the second and fifth, so it is 0. And for the third and fifth, we have this 20 ohm resistance, so it is minus 20. And for the fourth, nothing is common, so it is 0. Then for this fifth loop, we have this 20 and 60 resistances available. Okay, then we have this I matrix followed by this. For this, here we can write this as, for the first loop, it is here to here we are going, so it is plus 30. Then in the second loop, no voltage source is available, so it is 0. Then for the third one, it is, so it is going in this direction. Okay, so it is minus 12. And for the fourth loop, it is going from here to here, so plus 2 minus, so it is plus 20 volts. And for the fifth loop, it is flowing in this direction, that is plus 2 minus, so it is minus 20. Okay, so we have added all the values together, so to get this 150 minus 20 0, minus 80 0, minus 20 65, minus 30 15, minus 15 0, and here it is 0, minus 30 50 0, minus 20, minus 80, minus 15 0, 95 0, then 0 0, minus 20 0, 80, multiplied by I matrix equal to this voltage matrix. Okay, So we got this answer. Now we are going to compare our answer with the answer given in the book. Okay. So we have some differences. Okay. So here it is 150 and it is minus 20. In the book it is given as minus 40. Similarly here also it is minus 20. It is given as minus 40. But I hope our answer is the correct one. Okay. You can also check it. Okay. Thank you.